myself. So we had three options after getting out of college: either to work under someone, or start your own business, or go back to your family business, which was farming. Given the current scenario, I felt that it was not a can be a good option. But we went on to start CS Metal Reclamation. 1991 we started out as a private firm. 1994 entered the railways for reclaiming camshafts. When we started with an objective to reclaim ferrous and non-ferrous objects. That was our main objective. In 1994 we found this huge opportunity in railways which wanted camshafts to be reclaimed. By 2000 we became the largest reclaiming company for the Indian Railways. 2002 we entered into manufacturing of camshafts. 2004 took up our own expansion, wherein we went from the conventional method of manufacturing into the CNC method of manufacturing. That is when we got introduced to Mastercam first, and thereafter to SolidWorks. Thereafter, through 2006, 8 and 9, we have been manufacturing camshafts for especially very large engines. We don't manufacture automotive camshafts, we manufacture camshafts for the heavy-duty diesel engines, anywhere between 2,500 to 4,000 HP engines. And today our camshafts are exported to US, Canada, Mexico and Vietnam. We started up with an investment of $7,500 back in 1990, and today we have pumped in more than about $3 million USD to put up a fully integrated plant, having around 75 people working with us. A plant wherein from the raw material up to the delivery of the product is all done in-house. There are no subcontracting out here. We have a full-fledged inspection and metrology lab, which for camshafts, especially the material is important. Thereafter the machining process, the precision of machining is also important. And CNC CMM equipped machine to measure the profile. We also manufacture another very special product which is called high pressure pumps used in air conditioning and refrigeration, wherein I'll touch upon that now. Our camshafts is what you see here. These are not small shafts, these are anywhere between 1 to 1.5 meters long. And today we supply more than 60% of the Indian Railways requirement for camshafts for all the engines. So in 2002, when we had to move in from the conventional manufacturing process into the CNC type of manufacturing process, that is when we had approached Syntec, and that is where we got introduced to Mastercam, because we were developing a cam grinding machine with the help of Prasad NC machines. Why we choose this package was one, yes, I recall a previous speaker, Mr. Kaushik, said that using yesterday's tools for today, put your business tomorrow. Yes, we understood that. So we looked at all these factors. Yes, these all meant sense to us, but the most is the excellent service and support rendered by Syntec Technologies, because we were for the first time entering into the CNC area, and we had absolutely no idea of how the CNC machines worked. And I remember when we were testing these machines, especially the cam grinding machine, which is a unique machine manufactured first time in the country by Prasad NC. 10 days, day and night, Syntec engineers would be with us to try it and test it to get to the accuracies of roughly about 4 to 5 microns on profile accuracy. So, application of SolidWorks and CAM in CS is we use SolidWorks for converting customer 2D drawings into 3D drawings for better understanding of load profiles, overlaps, inaccuracies in assemblies, because these camshafts, when you assemble them, they are roughly about 4 to 5 meters long, and these are used in engines which are anywhere between around 6 meters in length. And today we are also looking at using SolidWorks simulation package to understand the various stresses that come under during motion. So there is one area where we are looking at it. And on the pumps, yes, these pumps are, a brief on the pumps is, these pumps are refrigerant pumps used in HVAC equipment in order to save power. So this is a patented product, manufactured specially for Carrier France and some of the other companies in Europe. So we use these pumps in SolidWorks to design. And one of the criterion here is the pump should be able to withstand very high pressures. So this is the models which we do. And for this pressure, when this subject came up to us, we were contemplating on how do we test it. You can't make a rig for each design. It costs a lot of money. So that is when we were introduced to SolidWorks Simulation Experts, where we would do a design, put it onto the test mode and test it. And this is one of the designs where you would find your von Mises stresses around the temperatures, which is a failure area on those red areas. After modification, you would find that we have got rid of this. So similarly, this is a rare housing on which you will find a lot of areas where it suggests that failure mode is evident. So now again, you don't have a restriction on material. You can change your material for a much higher yield strength, or if you have a restriction on the material, then you will have to change your dimension, and this is what we did. And these pumps operate at anywhere between about 1500 psi in the refrigerant circuit, and for especially carbon dioxide refrigerants, these pressures are required. What we propose to do for in the future is in the pump manufacturing area, you have four major components. One is the type of liquid you want to pump. The second would be the type of impeller. The fourth would be the speed of the impeller, and finally is the volume. Today we are at designing the volumes. In order to move up, we would require to further look into the CFD module of wet pump units. And for application of in the camshaft area, we are looking at the motion module just to understand the stresses, especially when as you move, as engines become efficient. You would have heard of the CRDI, common rail diesel injection, where you atomize your fuel and start putting a lot of pressure. So what happens is these pressures start forcing on the camshaft. So we need to understand what are the stresses on this camshaft and whether the current material can take it. But of course there is an issue. I don't know how the motion module is going to handle heat-treated component, because generally when you do not a true heat-treated component, when you do a surface heat treatment, your properties change. I'm not sure how SolidWorks can handle it, but the discussion with this Madhu informed that he could do something on that. And this is some work we have started with Simtech. We have given some information, and they are developing the CFD module for us to understand. So I have just given some pictures on how we propose to go about introducing CFD product. This is where I come to the end of this presentation, and I thank the organizers for giving me an opportunity to present my company and the usage of SolidWorks, and I also thank the audience for patiently lending an ear to my presentation.